let's start the session. Yeah. Yeah, today I'll explain about, actually we completed all the synopsises, am I right? Even we have done the questions also. Let's revise all the synopsis once again with questions. Understand? Yes or no?
Yes, sir.
Yeah, I'll revise all the questions. Now today I'll revise the first chapter, the 4. The first chapter, force. Okay? We have a first chapter, force. The chapter force I'll revise. Understand? Yeah. So simply way, in a simple way, I'll revise chapter force. Okay? So here, chapter name is force. Force. What is the force here? Force is a force. What it will do? Force is a cause. It will give the motion of an object. Understand? Even it can change the shape of the object. It can change the velocity of the object. It can change the direction of the object. So this is the way the force will do. So what is the units for the forces? Can you tell me units for the force? Units for the force. In which units you will measure the force? You will measure the force in Newton. You will measure the force in Newton. So simply N. And it is a what kind of quantity? It is a vector quantity. Vector quantity. What is mean by vector? Vector means any physical quantity having magnitude and direction is known as a vector. Understand? Any physical quantity has magnitude and direction is known as a vector quantity. Understand? Are you there, Avinash? Yeah. Now we have different types of the forces. Okay, let's see the types of forces here. What are the types of forces? Types of forces. Types of forces. How many types of forces in generally we have? We have two types of. What are they? Contact force. And next one is what? Non-contact force. So here example for contact forces are, tell me, what are the example for contact forces? Normal force, friction, muscular force, next normal force, spring force, and next spring force, next string force, tension force. These are the some example for what? Contact forces. So non-contact forces examples are what? Gravitational force, electrostatic force, and next what? Magnetic force. So this is the way we have the force names. Understand? Now actually about force explained by Newton actually. About force mostly explained by Newton. So in the Newton formula, Newton have three formulas. First law, Newton first law is explained about inertia. Okay, Newton first law is explained about inertia. Understand? Even he explained the concept of force. So this is a two things I have explained in Newton first law. Coming to Newton's second law. In second law, he explained about force, formula for force. What is the formula for force? Force is directly proportional to change in momentum. He given that force is directly proportional to change in momentum, and final equation is force is equal to mass into acceleration. Here m means mass, a means acceleration. This is what in Newton's second law the Newton have explained. Next, in Newton third law, he said that every action there is a equal and opposite reaction takes place. Every action equal and opposite reaction takes place. So the the thing is F12 is equal to minus of F21. This F12 is a action force, F21 is a reaction force. Both are equal and opposite direction they are acting on a different bodies. So this is what explained in Newton's third law. So this is the synopsis you have, and finally, even though these many forces are acting, but how do you find a net force, a equivalent force? You can find equivalent force by using a free body diagram. You know free body diagram means it is a diagram which represent the all forces are acting on the body. So this is what you have all the synopsis. Now based on this we'll do some questions. Okay na? We'll do now some questions. So this is you are already you have in your book these questions. Now we'll do this. Tell me, weight of weight of an object is always directed. In which direction the weight of the object always? First option vectorially downward, vectorially upward, parallel to the surface, inclined. Which one is right answer? Which one is right answer? Weight, he is asking about weight kada. Weight always acts downward direction. So what is that? So the first option. If you take any body, this is a body. If this body have a mass m, its weight acting which direction? Downward direction, that is actually mg. Understand? Next one, the component of the contact force perpendicular to the surface is called. Component of a contact force perpendicular to the surface is called. Component of contact force perpendicular to the surface is called normal reaction, frictional force, weight, speed. See, if this is a, again same here, once again look at here, same body, this is a body, if this is a body, it is on the surface. If this is having mass m, mg will act downward direction. Am I right? When mg is acting downward direction, in which direction the normal reaction will act? Normal reaction act upward direction. But observe the thing here. This is a surface. For this surface, which force is appears normally and acting? Which force is acting perpendicularly and with upward direction? So look at here, the component of force acting for perpendicular to the surface is called. So perpendicular to the surface is actually here two things are there, normal reaction, weight. These two will act, but here most appropriate answer is normal reaction. Understand? Next, the number of, third question now, the number of normal forces acting on a body depends on, the number of normal forces acting on a body depends upon number of points or surfaces of contact, mass of the body, color of the body, both A and B. So how both A and B? So here it does not depend upon, only the contact force or normal reaction only depend upon the what number of points surface contact. Okay, so because what is mean by normal reaction? When normal reaction existed, the normal reaction existed when objects are in contact. Understand? Objects are, for example, a freely falling body. It is a freely falling body. For a freely falling body, can you define a contact force? Can you apply a contact force here for a freely falling body? When an object is falling freely, how many forces are acting when it is falling freely? How many forces? What are the four forces? Can you tell me?
Friction, normal force, weight.
Yeah, look at here. When an object falling freely, only one force will act, that is gravitational force. The gravitational force also known as the weight of the body. It will act which direction? Always downward direction. Understand? When only one force, that is the reason in this direction force is acting, that is the reason object moving downward direction. But whereas same object if it is in the table, on the table, how many forces will act now? Mg will act to downward direction, but when mg is acting downward direction, is the body moving downward direction? Is the body moving downward direction? When mg is, why the body is not moving downward direction? Because this surface is applying some force. Because of the force application of this surface, the body is not moving. That force is known as normal reaction. Due to this normal reaction is applied by whom? Surface here, so that the normal reaction is not allowing to move downward direction by the surface. So here, what is the conclusion here? The conclusion here is the normal forces depend upon what? The number of points or the number of surfaces of contact. It does not depend upon the mass of the body, even does not depend upon the color. So the answer is what here? The answer is first option. Understand? Next, the free body diagram of the freely falling body. Neglect air resistance. Tell me what is the answer? Option B. So free body diagram of a freely falling body. For a freely falling body, how many forces will act for the freely falling body? How many forces will? Only one force. So in among the following diagrams, which diagram shows the one force? So option A is a correct answer. Next, a book is laying on a smooth horizontal table. Then the free body diagram of the book is. So book is laying on a horizontal surface kada. The book is laying on a horizontal surface. What is the free body diagram of the book? Option C. How option C? What are the forces are acting? Mg is acting downward direction, but the surface of contact is applying normal reaction to not to move the book downward direction. But normal reaction will act which direction? Upward direction. So which one is correct here? Option C is correct. You are right. Understand? Now let me share one more slide for you. Is it appearing? Yeah. A book is moving on a rough horizontal table. In the free body diagram of the book, friction F is a friction force. So now a book is laying on a rough horizontal surface, rough horizontal table. Then the free body diagram of the book. So free body diagram means It is representing the forces which are acting on the body. So tell me, object is moving this direction. Object is option D. Why option D? How?
Because if you moving object must have force and friction and normal force and gravitation.
Very good, very good. You are right. See, as it is moving on a rough surface, so now friction force will act this direction. Normal reaction act, mg will act downward direction. Normal reaction act upward direction. So option D will come. Next, same way, tension force always dash a body, push a body, pulls, sometimes pushes, sometimes pulls, both D and B. Which one is the correct answer? Yeah, observe, for example, this is a toy. For example, this is a toy. Okay. Now you tied a thread for the toy and you are pulling this. Now when you are pulling this, is the toy moves or not? When you are pulling this toy will move or not? In which direction it will move? In this direction it will move. Yes or no? Very good. When? Why? It will move in the direction of the pulling of the toy. Now same thing, if it is pushes, if we push this thread, is it the toy will move? Push the thread. If you push the thread, toy will move. You are not applying your common sense. When you pull the body, okay, when you pull the body, surely the toy will move. Gada. Same, if you push the thread, I am not talking about toy. Why? Because this thread gets slack. The thread gets slack. When thread gets slack, it can't have the tension force. When the string is not having the tension force, it will not unable to push the body or toy. Understand? So that what is the answer here? Only tension force always what kind of force? What kind of force? Pulling forces only. Tension force always pulling force, not pushing force. Understand? Next, 8th question. The free body diagram of the block M as shown in figure is. The free body diagram of the block as shown in figure is. What is the answer? Free body diagram. Why option A? How many forces are acting on the body M? What are they? mg will act downward direction, that is called weight. Tension is acting upward direction. So what is the answer? A is your right. A is the correct answer. Next same way. Tell me the second question. Tell me.
Option B, sir.
What is that question here? A free body diagram of the block EM has shown in figure is. What are the forces are acting? Here, they are talking about this force. What are the forces are acting? Surely, weight will act downward direction. Normal react upward direction. But it is tied with a string, so string force also acts this direction. Totally how many forces? 3 forces. So what is the option here? So surely the option B is correct answer. You are right. Next, 10th question. A free body diagram is a diagrammatic representation of a single body or subsystem of the bodies showing all forces are acting on it. That is the first option. Second option is diagrammatic representation of a single body or subsystem of a body without showing all forces are acting on it. So which option is right among the two?
Option A, sir.
Option A. So when option A, the remaining options will not work. So option A is final. Understand? Next, I'll go for the next slide. Yeah, is it appearing to you? Yeah. In a free body diagram, the object of interest is isolated from the surrounding. B. Interaction between the object and surrounding are represented in terms of forces. Both A and B, both neither A nor B. So what is the things are right here? In a free body diagram, the object of interest is isolated from its surroundings. What is the first option? Is it right or wrong?
No,
Why? Reason?
because it will show all the forces are acting.
Yeah, when, look at here, when you will show all the forces from the system, first of all, to draw the free body diagram, I given some points to you, how to draw the free body diagram.
Yes, sir.
In that, if you see, the first point is isolated the system from the, isolated the object from the system, I said. So in that case, the object of interest is isolated from the surroundings or not? So the option A is correct.
B is also correct.
Option A is correct. And the option A is correct. Look at the B. Interaction between the object and surroundings are represented terms of forces. Yeah, this is also correct. So that what is the answer here? Answer C is correct. Understand? Next, 12th one. A book is kept on a table. The force acting on the book can be directed in FBD as. The force acting on the book can be directed FBD as weight of the object, normal force exerted by the table, normal force exerted by the book, both A and B. So what is the answer? What is the answer?
Both A and B.
Yeah, you are right. Force acting on the book. Only they are asking force acting on the book. How many forces will act on the book? Two forces will act on the book. One is weight of the book. One more is normal force exerted by the table. These two forces are acting on the book. So this is your answer. Next, a boy of mass 40 kg climbs up a rope with an acceleration of 2 meters per second. What is the tension in the rope? So we can solve this problem by seeing the free body diagram. Imagine this is a rope. Imagine this is a rope, and a boy, even you can imagine a boy. Imagine a boy. He is climbing. He is climbing with how much acceleration? He is accelerating with 2 meters per second square. When he is climbing with 2 meters per second square, what is the tension in the rope they are asking? So now to find the tension, imagine this man as a object. So on the object, how many forces are acting? The object having how many kg? The object having 40 kg. Understand? So weight of the 40 kg will act downward direction. Tension will act upward direction, but the block is moving with 2 meters per second square acceleration. Now by using this data, net force acting on the body I can write as tension minus mg. But according to Newton's second law, the tension value is, net force value is mass into acceleration T minus mg. From here tension is equal to mg plus ma. Here mg is nothing but weight of the body. Weight is nothing but 40 into 10 plus 40 into 2, totally 400 plus 80, totally 480 Newton is the tension force. So what is the thing you can write here? 480. Actually, C option is correct, because here I took here G value as a 10. If you take 9.8, surely you will get 472 is the right answer. 472 you will get, because if you multiply with 10, you will get 480. If you multiply with the G value as 9.82, you will get 472 Newton. Understand? Better note down this solution. Next one, ropes become slack when tension force becomes. How much is the tension force if the rope becomes slack? What is the tension force? Unity, infinity is 0, none of these. Which one is correct? The answer is 0, because when you pull the rope, it will get tightened, and when it is get tightened, it will have some tension force. Same thing, if you push the rope, it will get slack. When it is get slack, no tension represent in the rope, so answer is 0. Next, the apparent weight of a person is equal to true weight of the person when the lift is. The apparent weight of the person is equal to true weight of the person when the lift is at rest, freely falling, moving vertically up, moving vertically down. So answer is, for this question is, answer is at rest. Okay. Next, the passenger in a lift will be in a static of weightlessness when its lift is moving with at rest, freely falling body, moving vertically upward, moving vertically downward. So option B is the correct answer. Understand? Next, look at the single correct one more. A person of mass m is on the floor of a lift. The lift is moving down with a acceleration a. Then the net force acting in downward direction is equal to the mg. The net force mg must be greater than reaction force. The man appears to be lighter than true weight by factor of a by g. So here this option is right, third option is right. The net force acting downward direction and equal to 0 when lift is moving upward or downward. So this option won't come. First option won't come. In the force mg must be greater than reaction force. So now not force must be greater than reaction force. This is also wrong. Only which one is correct? See, third option only correct. Third option only correct. But did not mention third option, only third option only correct. Okay, keep it in mind. Next 18th one. Look at the 18th one. If 4 equal forces are acting on a body and the body is in equilibrium, then which of the following is wrong? Why A is wrong? No, he is telling that wrong option. So he said equilibrium, the equilibrium means sum of the forces must be equal. So here for this body, this side two forces, left side two forces are acting, so that here you will get the net force is 0. So when net force is 0, this is the wrong option. You said wrong kada? I mean, you said wrong one, so that this is correct one. So it is not our answer. Even this is also not our answer. And here, this would be your answer, because upward acting, downward acting two forces, upward acting one force. So it not be, you will get something net force. So the option C is your right answer. Option C is your right answer. Now next, let me share one more slide for you. Yeah, these are the one more slide. Is it okay? Next, a lift is moving down with an acceleration of 10 meter per second square. If g is equal to 10 meter per second square, the weight of the man is. See here, when the lift is moving with a 10 meter per second square, which means that weight of the body and acceleration of the acceleration due to gravity and weight acceleration of the lift both are same. When these two are same, that will be freely falling body. For a freely falling body, weight is 0, so option A is correct answer. For a freely falling body, option A is correct answer. Next, in which of the following cases the apparent weight of a person in a lift changes? When lift moves with uniform velocity? No. When lift moving with uniform velocity down, this also wrong. When lift is at rest, this is also wrong. Lift moves up and down with acceleration. So option D is your right answer. Okay. Now let's take this 22th question. Blocks A and B have 2 kg and 3 kg respectively. The ground is smooth. P is the external force 10 Newton. The force exerted by the B on A. Look at here. To know that, you are supposed to write, so you are supposed to draw free body diagram of both blocks. So these two are the blocks here. One block is A, one block is B. See, on the block A, how many forces are acting? 10 Newton is acting right direction. The normal reaction by the B in the left direction. This is the, and next weight will act this direction. Normal reaction act upward direction. Same way for B, normal reaction applied by A would be this direction, that is NA, N dash you can take, this is also N dash. Okay, next this is in this direction, normal, this is 1, this is N2, this is in this direction, this is 2G, this is 3G, so this is your. Now let us assume that for this body MA is equal to 10 minus N dash, MA here 2, it become 2A. For same thing for here, 3A is equal to N dash. Next you can apply this N dash in a above equation. 2A is equal to 10 minus 3A, 5A is equal to 10, 5 1s are 5, 2s are. So acceleration is 2 meter per second square. Once you know the acceleration, it is easy to find the normal reaction between A and B by using this equation. 3A is equal to N dash. N dash is the normal reaction between B and A. Then N dash is equal to 3 into 2, which is equal to 6 Newton. So option, which one is correct? Option B is correct. Understand?
Yes, sir.
Yeah, anyhow, for today we'll stop the session. In the coming next class we'll discuss another chapter problems. Okay na? For today
Okay, sir.
I'm taking off. Bye.